All right, welcome back to Java Computer Science. My students requested that I put up the solutions for tonight's homework. I thought I would make a video to kind of explain the thinking. Some of these problems are pretty meaty. It takes some work getting through, so I figured we could take just 10 minutes and talk about it. Question number 1 asks us to review the following code snippet, which is a bunch of nested for loops. Loops A, B, C, and D are in serial. They're in order inside of an outer loop that runs 5 times. For each of these loops, we were asked to consider, are they incrementing or decrementing? If I is 0, how many times will the loop run? Is it expanding or reducing or constant? And what we mean by constant is regardless of whatever the index of the outer loop is, in this case, the index of the outer loop is I, would we get the same outputs? That would be constant. If as I increases, as we loop the outer loop more, if we get more output, I would describe that as expanding. If we get less output, I would describe that as reducing. So for loop A, get rid of you. For loop A, we're looking at the question, is it incrementing or decrementing? I'm always going to look at the updater here. J++, we're sending our index in the upward positive direction, so I'm going to say that's incrementing. And how many times does it run when I is 0? Well, let's see here. If I is 0 here, I can just imagine instead of looking at I, that I'm looking at a 0. So I'm going to ask the question when j is 0, j less than or equal to 0. Well, it seems like that's going to run when j is 0, but as soon as j gets updated to 1, 1 is not less than or equal to 0. So it won't run again. So it's going to run once. The last question, is it expanding, reducing, or constant? Well, if it starts by only running once, as I gets bigger, the outer loop is an incrementer, it's going to count up. As I gets bigger, we're going to see that j has a further and further distance to go, right? First it counts from 0 to 0. Then it's going to count from 0 to 1. And then from 0 to 2 to 3 to 4. That means that I would describe this as an expanding output. Okay, so that's loop A. Let's go into loop B. The updater is again positive, plus plus, so we are incrementing. How many times does this run? Well, when I is 0, j will go from 0 to 5. So it seems to me like it's going to run 5 times. And is this one expanding or reducing, or is it constant? Well, I is 0 and it has to count to 5. Every time I increases, when I goes to 1, that's going to shorten the distance between the initialization and the test. When I goes to 2, that distance gets even smaller. I goes to 3, smaller still. So what I'm seeing here is it's a reducing output. Okay, on to loop C. We'll start speeding up here a little bit. The updater says we're going downwards. This is our first decrementing loop. We start initializing at 5. If j is greater than 0, if 5 is greater than 0, that means that we're going to run 5 times to start. And we see that I will continue to increase and increase, giving the distance that we cover, it's going to be smaller and smaller. So again, that's reducing. And then loop D, j starts out at 2, and we're counting down, so that's again decrementing. It's going to run 2 times because we got to count from j to 2, j down to 0. And this one's actually going to be constant. And the reason this is constant, the reason we're going to point this out is because if you look, nowhere in my for loop did I use the index of my outer loop. We don't see I anywhere in here. For loops A, B, and C, they all cared about I, whether it was in the initialization, whether it was in the update. When I was different, the loop ran differently. That's not true here. Because 2 is a hard number, 0 is a hard number, it doesn't change. We're going to get the same number of those vertical bars, same number of pipes every time. All right, so that's that. So let's talk about what the output's going to be. So every row is going to have, it's going to start with an exclamation point, a bang, and then we're going to say, I'm going to need some number of i's. I is going to be the index of the outer row. It looks like because it's expanding, I'll have 1, 0 on this first row. But on the next row, I should expect to have 2 1s. And on the next row, I should expect to have 3 2s, and so on and so forth. So let's plug that in. So we knew that we're going to get 5 rows of output from our outer loop. When I is 0 up through when I is 4, when I reaches 5, the outer loop will terminate. So I'm going to have 5 rows of output. 1, 2, 3, 4, 5. Because we have an incrementing, expanding inner loop that is printing out the index of the outer loop, I would expect the output to be 0 the first time, then 2 1s, and 3 2s, and then 4 3s, and then 5 4s. And let's just double check the math on that last one. When I is 4, we will count from 0 to 4. We get to include the 4, and we're asked to print out I that many times. So when j is 0, 1, 2, 3, and 4, we'll print out I, which is 4. So I think we've met the needs of loop A. All right, so proceeding next, what else comes on each of our rows? Well, next would be loop B, and it's going to print out a number of x's that is reducing. So when I is 0, 0 to 5 means I should get 5 x's. When I goes up, I will be 1, and then we have to count from 1 to 5. That means it will only get outputs when j is 1, 2, 3, and 4. So now I only get 4 x's. So we'll start with 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. Let's make sure we got that last one correct. When I is 4, we're counting j from 4 to 5. It's only going to run once. So that makes sense to me. All right, for loop C, we have another reducing output. This time we're printing out j. That's going to be the index of this inner loop. J will always start at 5, and then it'll start counting down. When we're first time through the loop, j is 0. That means we're going to print out for when j is 5, 4, 3, 2, and 1, but not when it gets to 0. So I think the next output on this one's going to be 5, 4, 3, 2, 1. Then on the next loop, when I is 1, j will print when it is 5, 4, 3, and 2. So we'll say 5, 4, 3, 2. Then it should go 5, 4, 3. Then it should go 5, 4. And I think it just goes 5 because we'll run when j is 5 and I is 4, but not when, let's see here, when I is 4 and j is 5. Right, it has to count down. Yeah, that's right, that's right. So we've got 5, 4, 3, 2, 1, 5, 4, 3, 2, 5, 4, 3, 5, 4, and 5. The last one is, then we get a single individual @ sign. That looks good. So let's add that to each of our rows where that would be printed. And lastly, we have to print out these vertical bars. I think the programmer slang for that is called a pipe. So we get a couple of these on every row. Whoops. And then we're done. That is the solution for questions 1 and 2. Looks like that. All right, moving on to the back page. We want to produce some nested for loops that produce the following outputs. Well, I want to look at one slice at a time of these outputs. And what I see, it might look like there's only numbers there, but because we are lined up on the right as opposed to the left, we had to push all of these numbers to the right with some number of spaces. So if I were to map out just a little bit of pseudocode here, I'm thinking to myself, I want an outer loop that runs 5 times, but then I'm going to need 4 inner loops. Excuse me, I'm going to need 2 inner loops that are for loops. One is going to take care of spaces, and it's got to be reducing. And the next one is going to be another inner loop. It's not going to be inside the other inner loop. It will be after this one completes, the next one runs. This one's going to be for numbers, and this one's going to be expanding. So that's what it looks like to me. So let's start building these things. I know I want 5 rows. So the outer loop's usually the easier one to write. Int I equals 0, I less than 5, I plus plus. Whenever I can help it, I'm always going to make my outer loop start at 0, end at a number, And whatever fancy math needs to be done, I'll usually take care of in the inner loops. I think that that's easier than trying to do fancy math in more than one place. Is that the only solution? Is that the best solution? No, but it's something I recommend you try out as a beginner. All right, so for the next one, we're going to say for int j equals, and then right here, I have to stop, turn my brain on, and ask the question, what is it I'm trying to do? Well, I need a number of spaces that's going to start big, and then it's going to shrink down. And to me, I think the easiest thing to do here is to say int j equals I, and then we're going to say j less than, and I'm going to say 4. And let me talk about my reasoning on this. The reasoning is going to be, if j starts out as I and counts to some constant number, counting up as an incrementer, well, I will have a big distance to start with. When j is 0, I have to count up. 0, 1, 2, 3 will be the things I produce an output on. But as I gets bigger, then it's just going to go 1, 2, 3, and then 2, 3, and then eventually just 3. And the reason I picked 4 is I don't need 5 spaces on the first row. I only need 4 spaces. So by counting from 0 to 4, I figured out what the right number of spaces were, and by mapping to I know that I will decrease the number of spaces I have in each line. So we're going to want a print statement right here. Print, not a print line. We don't want to goof up our formatting. So that takes care of the first inner for loop. Let's talk about this next one. So a little trickier because we're going to be expanding and we got to print out some numbers. So I'm going to say for int j equals, and I pause here to turn my brain on. I need something that is expanding, so it's got to start with a small distance and grow. So I'm going to say int j equals 0, and I like, let's see here, let's go with j less than or equal to I. Remember, if I'm going to have either an expanding or a reducing output, I have to include I somewhere in my for loop, so that every time the for loop runs, I will have changed, and then the number of times the inner loop runs should also change. So we're going to say j++, and let's talk about our thinking on this one. It seems to me that when j is 0, I is 0, we'll get one output because 0 is less than or equal to 0. But then the next time through the loop, I will be 1. And we will get to count from j from 0 up to j is 1. That'll give me 2 outputs. Then we'll go j is 0 up to 2. That gives me 3 because I get to, with the equal sign right here, I get to include it. And then we'll say, when j is 3, when j is 4, that'll give me 5 outputs. But then when j is 5, it will, the last time we're in here, I will be 4. And so the j will fail because 5 is not less than or equal to 4. So then we're going to say system, is that off by 1? It is. System.out.print. Okay, here's the trick. I can't do I. I would give me 0, 1, 2, 3, 4. That's not what I want. I can't do j, because I think actually that might do something similar. It would give me 0, but then of course j changes every time it runs. So it goes 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. I need to be able to start big. And my first clue for you is notice how all the numbers on each row are the same. This makes me think that I should care about the outer index right here. And indeed I do. Basically, whenever I goes up, I need this number to go down, which means I probably want I in some kind of a negative capacity. So let's do this. 5 minus I. Now look what that does for us. 5 minus I, well, when I is 0, we'll print out 5s. When I is 1, we'll print out 4s. When I is 2, we'll print out 3s. Bingo, bango, we're ready to go. System.out.print line, make sure we go down to the next line. Compile it, run it, haha, and we're totally good to go. All right, so that's the solution for number 3, A. 3B, we're going to do something similar. We need 3 rows, but now we've got 3 different patterns to compete with right here. I've got expanding numbers, reducing stars, expanding exclamation points, expanding bangs. What do I do? All right, let's get into it. I need an outer loop that's going to run 3 times. And just as we did in our previous case, let's keep it simple. I want for in I equals 0, I less than 3, I plus plus. Yeah. Let's not make that harder than it needs to be. I'm going to need an inner loop that is for numbers that is expanding. I'm going to need an inner loop that is for stars that is reducing. And I'm going to need an inner loop for bangs that is expanding. And so let's attack these things one at a time. Whoa. Okay. Nope. Awesome. Okay. So for, it's an inner loop, for int j equals, I stop, I have to turn my brain on. What do I want? I want to be expanding, which means give me a short distance to deal with the start, and then as I gets bigger, I need more ground to cover. So why don't we say int j equals 0, j less than or equal to I, j plus plus. What this does for me is this says, as I gets bigger, give me more distance to cover. System.out.print. What do I want to print? Well, it seems like I want to print the index of the outer loop, but I just happen to be off by 1. If I printed just I right now, it would give me 0s and 2 1s and 3 2s. I think I want to print out I plus 1. By the way, could you get your outer loop to run from I is 1 to 4? You could. That's totally fine. Does that mean that I think this inner loop changes from j is 0 to j less than I? I think so. That sounds right to me. Play around with it, see what you come up with. Throw it in blue j, see what comes out the other side. But this is how I would set it up. All right, so now we need stars. I'm going to let you in on a secret. Whenever there's an odd number like this, I feel like the math gets tricky. And to try and figure out a way so that when I is 0, I get a 5, and when I is 1, I get 3, and when I is 2, I get 1, that seems to me to be a little bit trickier. What I like to do is I like to cheat. I'm going to say, let's print out an individual star right here. And now all I need is some grouping of an even number of stars. Instead of 5, 3, 1, now I just need 4, 2, 0. I find those to be easier numbers to work with. People are going to disagree with me. Some of you are watching this and screaming and saying, the math is not that hard. Set up a formula for your inner for loop to produce 5, 3, and 1. That's fine. If that makes sense, do it that way. I'm going to try and do it the way that I think is the simplest to understand, and that's what I think this is. All right, int j equals 0, and we pause. What do we need to do? Well, we need a reducing output. And I'm going to jump ahead to the body of this for loop right here to express that I'm going to print out 2 stars at a time. Why am I doing that? Well, because that just means that when I is 0, rather than having this run 4 times, I'll just have it run twice. When I is 1, I'll have it run once. When I is 2, I'll have it run 0 times. So the nice thing is, I think the numbers are smaller. It's a little bit easier. I'm growing by 2 stars at a time. Let's print out 2 stars at a time, and then my loop doesn't have to run quite so many times. So it's a reducing output, which means I should probably have a smaller, I should have a large distance to cover it first, and then it should become smaller over time. So let's set int j equals to I, and then I'm going to say j less than 3. I think it's 3. Let's go through it. When I is 0, we will count from 0 to 3. Oh, I had it right the first time. My brain said 2, and I think it's 2. When I is 0, j will start out at 0, which means that we'll run when j is 0, when j is 1. So the first time through when I is 0, this loop will run 2 times, giving me 4 stars. Added to the 1 star I had before, that gives me 5 stars. When I is 1, we will run when j is 1, but not when j is 2, so it only runs once. That gives me 2 plus 1. That gives me my 3 stars. When I is 2, j will start at 2, but j is not less than or equal. It's not less than 2, it's equal to 2. So this will fail. So when I is 2, this loop's not going to run at all. And that gives me just the one individual star I want. Again, is there a way to incorporate some fancier math in here so you don't have to do this? There is. Is there a way to change this for loop so that you could just print out one star at a time here? There is. Do I think this is the cleanest, simplest? I do. It's a matter of personal programming taste, I would say. All right, here's the cool thing about this second inner for loop. It follows the exact same pattern as our first expanding for loop right here. But instead of printing out numbers, I'm printing out exclamation points. So let's do that. Let's just copy. And why reuse? Oops. Except this is no longer numbers. It's for the exclamation points. And I'm going to print out the string literal exclamation point. Oh, no. I'm in such a habit of hitting Control or Command K to compile that I just accidentally did. There is your solution for 3B. We've got one to go, and then you're almost done with this video. And then let's just trim this out of here. Okay. Oh boy, we made extra space. Let's get rid of that. All right, I've left myself a note to change this to x plus plus. I think x plus equals I is perhaps a little bit too severe. But here's how I see this problem. It seems to me that we have a triple nested loop. It's pretty intense. The outerest loop runs 4 times. Middle loop is going to run 3 times, and then the inner loop is going to run a number of times dependent on the indices of the 2 more outer loops. Whew, what a good problem. This is probably an extra credit problem in its current form. If I change this to x plus plus, maybe it's a harder question on the quiz, like the hardest question on the quiz type of problem. But here's how I would break this down. If you ignore the inner loop for right now and you just ask yourself, what are these 2 more outer loops doing? Well, the outer loop runs 4 times, middle loop runs 3 times. That means that whatever I'm highlighting is going to happen 12 times, right? So the scenario is when I is, oh, don't do that. There we go. When I is 0, j is going to run 3, 2, 1. Let's see, 3, 2, 1, but not on 0 because 0 is not greater than 0. Then when I is 1, j will run 3, 2, 1, but not on 0. Then I is 2, oh boy, 2, and we get 3, 2, 1, not 0. And then I is 3, and we get 3, 2, 1, but not on 0. So every time one of these j's happens, they're triggering an inner loop. This inner loop, that's the k index loop, so I'm just going to call it the k loop. And then it's got to run a number of times equal to I plus j. So what is that? So we're going to say k, well, right here, it's going to run I plus j times, that's going to be 3 times, then 2 times, then 1 time. And it's going to count down from that number, from 3 down to 0, adding up whatever the I value is every time. So let me just get what the values are of k every time we do this loop. And I'm just going to get that by adding together I and j. So we'll have 4, 3, 2. We'll have 5, 4, 3. And we'll have 6, 5, 4. Just double check, make sure this matches my notes. Believe that it does. Excellent. Okay. So then we have to go 3 times, then 2 times, then 1 time, adding up whatever I is on any of these basic times. Well, here's your first hint. When I is 0, I get nothing, right? Because I'm just adding up a bunch of i's. I's are nothing right here, right? When I is 1, then each of these is worth 1. So if I run this loop 4 times, Then the next time through, I'll run it 3 times. Then the next time loop through, I'll run it 2 times. And each of those was worth 1. That means after the I is 0 iteration, the total was 5, because just to be confusing, we started this value out at 5. After this time, it's every time through is worth whatever I is. So 4 times through, 3 times through, 2 times through, that's 7. 1 more makes 9. Now here, every time we loop, we're going to add 2. So 5 plus 4 plus, oh my gosh, I'm sorry. 4 plus 3 plus 2 is 9, but added to the previous 5, now we're at 14. I knew that didn't look right. Okay. So x is currently 14 after we have completed the I is 1 loop. All right. Now we go again. 5, 4, 3. That's going to be 9 plus 3 is 12. Each one of those is worth 2. So that's 24. 24 plus 14 is 38. So that's our current number there. And lastly, we're going to run 6 times, then 5 times, then 4 times. And every time we're going to add in a 3. So 6 plus 5 is 11, plus 4 is 15, times 3 is 45. 45 plus 38 is 70, 83. Is that 83? I'm going to double check my math one time. 6 plus 5 is 11, plus 4, 15, 45, 78. Yeah, 83. I believe the answer to this to be 83. Again, do we expect to see this on the nested for loops quiz? We don't. But I wanted to give you a memory table strategy for how to attack a problem like this. Whew. If you made it this far into the video, if you've watched this whole video, and 1, I applaud you. 2, the code word for this video is pineapple. The first 5 students to come say pineapple is the secret word. You can have a piece of candy from the candy jar from my classroom tomorrow. Whew. Nice job, nice job. Okay, thanks very much.